What is going on, everybody, and welcome to part 7 of the Raspberry Pi tutorial series. In this video, what we're going to be doing is wiring up the distance sensor. Now, to do this, we're going to need quite a few things. We're going to need a actual distance sensor. That's the HC SR04. And then we're going to need 4 male to female jumper wires. And then we're going to need 3 1K ohm resistors, or you could have a 2K ohm resistor and then 1K, or any way to make 1K and 2K ohms. So the VCC, trigger, echo, and ground. I'm not sure how well you can see that on camera. It's probably not focused. I turned off autofocus. But anyways, it says right here on each of the pins what they are. So the VCC, that's your power. Trigger is the sensor. Basically, it's going to shoot out. So basically, when you trigger the trigger, it's going to shoot out some sound. And then the echo is the input, and that measures when the input actually occurs. And then GND is ground. So with that, let's go ahead and connect everything. All right, once you've got everything hooked up, you've got the Raspberry Pi turned on, you're ready to measure distance. So let's go ahead and CD into desktop, and then let's nano distance sensor.py, and we're ready to begin. First, we're going to, just like before, import rp lowercase I dot all caps GPIO as all caps GPIO. We're going to import time GPIO dot set mode GPIO dot BCM. Then we're going to define trig as 4 and echo as 18. So the reason why we're doing this is, if you didn't notice before in the previous tutorial, if you followed along with the LED lights, just hard coding each of the pin values every single time can be pretty tedious, and as you make a larger and larger program, it's going to get out of hand should you ever need to change those pin numbers. So you probably just want to give them a constant right at the beginning of the script rather than typing it out. So that's why we're doing that. Next, what we're going to do is GPIO.setup. We're going to set up the trigger pin to be a GPIO.out, and then GPIO.setup the echo pin. That's going to be a GPIO.in. So the trigger sends out a burst, and then the echo takes it in. Using the known constant that is the speed of sound, we can calculate how much distance was traveled based on how long did it take for that sound wave to go out and come back. So, once we've got that, we can go ahead and begin that with a GPIO.output. Oops, we forgot our dot. Or did we? No, my mouse was in the way. I didn't see it. Anyway, GPIO output trig true. And then we're going to do a time.sleep for 0.0001, something like that. Something good enough to just give it a moment's rest. Then GPIO, or a moment to do what it needs to do, dot output trig false. Then what we're going to do is we're going to say, wow, the GPIO dot input to the echo is equal to false. So long as that's the case, we are going to say start equals time.time. And then we're going to say, wow, GPIO.input, oh my goodness, there we go, echo equals true, end will equal time.time. Then we're going to say the sig time is going to be end minus the start. And then we're going to measure the distance. Now for centimeters, if you want inches, you can go to the text-based version. I break that one down there. I can also just say it as we code it out. Anyway, distance will be equal to the sig time, whatever that is, divided by 0.00058. So 4 zeros after the decimal point. If you wanted to do inches would have been 0.000148. Then what we're going to do is we're just going to print distance cm dot format distance. And then finally, when we're all done, let's run a GPIO dot clean up our mess. Control X to save, yes, that file. And let's do python distance sensor.py. And there we have a distance. If for whatever reason you get some sort of error or it gives you a warning, just run it again. And that cleanup should solve your problem. So right now we're reading about a 102, and then I'll put my hand in front of it. And now, yes, we've got a 21 centimeter distance. Okay, so now that we've done that, we've got the light, we've got the distance sensor. What I'd like to do in the next tutorial is kind of combine the two things and create something a little more complex. And for that, we're going to make a sort of like one of those like garage stoplights, where basically as you pull into the garage, it's a green light. As you get closer to the max distance you can pull forward, it turns yellow. And then when it's time to stop, it turns red. So we're going to make something like that for the Raspberry Pi, although instead of using a car, we'll just use our hand as we approach. And the closer that we get, it'll turn yellow and then finally red. So that's what we're going to do in the next tutorial. If you have any questions, comments, concerns, whatever, feel free to leave them below. Otherwise, I will see you in the next tutorial.